I hope that by now you know that work is force exerted over distance, force times distance. The easiest kind of work is if it's a horizontal problem, and about maybe half or a little more of your problems in the MCAS will be horizontal work problems where you're given the force and you're given the distance. And that could be easier, could it? Just plug them in, force and distance, use that formula and get your work of 3,600 joules. Horizontal work is one of the easiest problems you'll have on your MCAS. Now vertical work is a little trickier, isn't it? Because here, for instance, you're given the mass, aren't you? But recall, is mass a force? No, it is not. So if you recall, the force we use here is the weight of the object. So you must do this little calculation here first. The force is going to be the weight, which of course is mass times gravity, and mass here is 20, and g is always 10. So the weight of this object is 200 newtons, and that's the force we're going to use to lift it, 200 newtons. And then, at that point, you're back on easy street. Use the blue sheet format if you please. Plug it into that formula and you've got your same, you've got a work of 300 joules here. Here's your video code. But sometimes the MCAS kind of does you a favor, although maybe kind of a trick. They do you a favor and they actually do the weight calculation for you. Let's look at this one. Marco lifts a 200 Newton box. Isn't that a force? That's not mass, is it? That's force. In fact, that's the weight. They've given you the weight. Haven't they done this part of the problem for you? Haven't they done that? They have. So you don't need to do it, and you shouldn't do it. If you do it, you'll end up doing it twice because the problem's done it once for you. All right, so here what we do is this. We do not do this calculation here. A weight is mass times gravity. It's done for us. We just jump right in here. We just use the force of 200 newtons. And again, of course, we're on easy street using the calculation. So the trick here is to know when to and when not to do the weight calculation. Let's look at these two problems and see where we should and where we shouldn't do them. The calculation, the weight calculation. Which one is? What are you given here? You're given mass, aren't you? Do you think you need to do the weight calculation? Yeah, that's not a force. You'll need to do it there, won't you? How about here? Should say a box. I forgot. It doesn't say that, but what are you given? You're given the force, aren't you? You're given the weight. So what's going to happen here, and then from here, since you're given mass, you do need to do the weight calculation. You must do W equals mg. Over here, you're given the weight. Do not do the weight calculation. You've already got it, 200 newtons. So be careful. If you just read through quickly and don't really pay attention, you could mess this up. Here, you must do that little calculation first because you're given the mass. You must get the weight, and then use that in your work formula. Here, you should not. You're given the weight already, so you don't do that first calculation. Jump right into your work calculation. So you got to be careful. You got to read it and say to yourself, do I have mass or do I have weight? If you have mass, you need that first calculation of weight. If you already got weight, you don't. That's it, I think. Yep. Bye.